Welcome to The Explainer. Today, we're jumping into one of the biggest and, let's be honest, one of the most confusing buzzwords in tech, serverless computing. So let's cut through the noise and figure out what it's really all about.
I want you to just think about this for a second. What if you could build and run your applications without ever having to worry about provisioning a server, patching it, or figuring out how to scale it? That right there is the core promise of serverless, and we're about to unpack exactly what that means.
All right, here's how we're going to break it down. First, we'll define what serverless actually is. Then, we'll see how it works in the real world. After that, we'll get into the good stuff, the advantages, but also the limitations. And we'll wrap up with how to decide if and where it's right for you.
Okay, so first things first. What are we actually talking about when we say serverless? You know, the name itself can be a little bit misleading, so let's clear that up right away. And I love this quote because it just hits the nail on the head. Of course there are still servers. There are always servers somewhere. The whole point is that they are completely abstracted away from you, the developer. Your job is no longer managing infrastructure. Your job is just writing the code that actually matters. The cloud provider handles all the rest.
Okay, so let's get official for a second. The National Institute of Standards and Technology, or NIST, has the definition, and it highlights two absolutely crucial points. First, your code runs in response to events. Now, an event can be almost anything. A user clicking a button, a new photo being uploaded to a bucket, or even just a timer going off. And second, you are billed only for the actual usage. This is a huge shift away from paying for servers to just sit there waiting for something to happen.
Now, you're going to hear the term function as a service, or FaaS, thrown around a lot. And really, FaaS is just the most common way to do serverless. The name says it all. You, the developer, just provide a function, a small, self-contained chunk of code, and the service takes care of running it for you whenever an event happens. No servers, no platforms, just your code.
So, that's the theory. But what does serverless look like out in the wild? Let's take a quick look at some of the real-world services that actually make all of this possible.
You really can't talk about serverless without talking about AWS Lambda. This was the service that basically created the whole FaaS category. You upload your code, you connect it to a trigger, say an HTTP request, and Lambda just handles everything else, scaling up and down automatically to meet whatever demand you throw at it.
And of course, over in the Microsoft world, you've got Azure Functions. It's the same core idea, event-driven compute that lets you focus on your code. It's really tightly integrated with other Azure services, so it's a super popular choice for things like processing data from IoT devices or reacting to changes in a database.
But here's the thing. Serverless isn't just about functions anymore. The idea has grown. Services like Google Cloud Run and AWS Fargate let you take standard application containers, the kind you might already be building, and run them in a serverless way. So you get all the auto-scaling and pay-per-use benefits, but with the packaging format you already know and love.
And the evolution is going all the way to the edge of the network. Services like Cloudflare Workers let you run your code in data centers all across the globe, putting it physically closer to your users. And this is an absolute game changer for apps that need lightning-fast response times, like personalizing a website the instant someone visits. So we've covered the what and the how. Now, let's get to the most important question, the why. Why are so many developers and companies jumping on this bandwagon? Let's break down the biggest benefits.
For me, it really boils down to these 4 big wins. First, you have way less operational work. No more late-night server patching. Second, the scaling is automatic and it's incredibly precise. This frees up your developers to actually build new features, not manage servers. And finally, that cost model is so efficient, you literally only pay for the milliseconds your code is running.
And this chart just makes the difference so clear. With traditional cloud models, you're paying for reserved capacity. Think of it like renting a huge apartment. You pay for the whole thing, whether you're using one room or all of them. With serverless, you're just paying for the exact moment you flick on the light switch. Scaling is built in, not something you have to configure. And all that underlying management stuff, it's just gone. It's handled for you. But of course, no technology is a silver bullet, right? To use it well, you have to understand the trade-offs. And serverless definitely has some specific constraints you really need to be aware of. Let's talk about the gotchas.
The most famous challenge is something called the cold start. Basically, if your function hasn't been used for a little while, the platform needs a moment to spin up a new environment for it. And that introduces a small delay. For a lot of apps, it's no big deal, but for anything super latency sensitive, it's a critical factor you have to plan for.
Here's another hard limit you absolutely have to know about: execution time. On a service like AWS Lambda, your function can only run for a maximum of 15 minutes. That's it. This makes it completely unsuitable for those really long, continuous background jobs. Your tasks have to be designed to be short and sweet.
And there are a few other things to keep in mind. Cloud providers put a cap on how many functions you can run at once. Monitoring can get tricky because instead of one big app, you now have this distributed system of tiny functions to keep an eye on. You also run the risk of vendor lock-in, since you're relying so heavily on the provider's specific services. And, a little ironically, if you have a workload with constant high traffic, it might actually be cheaper to just rent that dedicated server after all.
Okay, so let's put this all together. With all these pros and cons in mind, how do you actually decide where serverless is the right tool for the job?
And this right here is the key takeaway for our entire discussion. The debate isn't about if you should use serverless in an all-or-nothing kind of way. The real smart question is where. Where are the specific parts of your system where this model is going to give you the biggest bang for your buck?
Here's a really simple way to think about it. First, define a clear trigger. That's your event. Second, build a small, self-contained piece of code that responds to it. And third, and this is super important, manage any long-term data externally. Your functions are stateless, meaning they have no memory of what happened last time. Every run is a fresh start. So if you need to remember something, you've got to save it somewhere else, like in a database.
So where does this pattern absolutely shine? Well, it's perfect for data processing pipelines that kick off when new data arrives. It's fantastic for simple APIs, especially if you have spiky, unpredictable traffic. It's a modern, amazing replacement for old-school scheduled tasks or cron jobs, and it's brilliant for real-time file processing, like, say, automatically creating a thumbnail the very instant a new image is uploaded.
And when should you maybe hit the pause button? Well, for those long-running applications that need to maintain a connection or remember things between requests. Also for any workload where you need deep, specific control over the operating system itself. And finally, like we mentioned, for those apps with super consistent, heavy traffic, where a good old-fashioned reserved server might actually save you money in the long run.
Which brings us right back to that central idea. Serverless computing isn't here to replace everything that came before. It is a powerful, specialized tool in the modern developer's toolbox. The real skill is knowing not if you should use it, but where to apply it so you can build faster, scale smarter, and focus your energy on what really matters, building great things.